Hello friends, I welcome you all to this session on C++ programming. So in this particular class or in this particular lecture, what we'll do is we will try to create two classes, one for series circuit and one for parallel circuit. Now the classes will be having the same data members, that is V, R1 and R2. So the task will be to obtain the current in the circuit and potential drop across V across R1 and V across R2 for both the cases, and then we will be doing what? We will be displaying the result, or even equivalent resistance you can also calculate, but let's say equivalent resistance also we will be calculating. So if you look this closely, so these are your data members. How many? 3, 1, 2 and 3. And the member functions will be the first the equivalent resistance evaluation, then the current, then the voltage drop across R1, voltage drop across R2. Now in case of series, the equivalent resistance will be nothing but the sum. Okay. Now the voltage drop across R1 will be what? It will be nothing but this current times R1, and the voltage drop across R2 will be the current times R2. Similarly, you have to first find out the current. So here we will be evaluating the current. So how to find out the current? V is given to us and we will be dividing it by equivalent resistance. So that's it. In the similar way, what we can do is we can also plan for the second case. So this will remain the same for the parallel circuit as well. Okay. Now we have to find out here the branch current. So current in this circuit, current in this circuit, in this resistance, current in this resistance. Okay. So the branch current, let's say I1, let's say this is I1. So I1 will be what? It will be basically the potential across it, that is V by R1, and across R2 will be, it is V by R2. Okay. Once this has been done, we can also evaluate the total resistance, total current, which is nothing but the sum of these two. Okay. Once this is also known, you can also evaluate what? The equivalent resistance. So what will be the equivalent resistance in this case? It is 1 upon R1 plus 1 upon R2. So in this particular case, you will be using your constructors also. Okay. So let us do it one by one. So let us do first for the series circuit. So let us create a class for series circuit, and this is having data member. Let's take voltage. Okay. Then resistance R1, then resistance R2, and that's it. Once this has been done, then your member functions will be public. Okay. So first we will be creating one constructor. Okay. And let us create both. So by default, let's say that it is voltage. Let's say I am taking 1, resistance R1 I am also taking 1, and resistance R2 is also 1. Once this has been done, then what you can do is you can solve for, or you can create your parameterized constructor. So double volt and double R1 and double R2. As C++ or C, they are what? They are case sensitive. So this R1 and this R1 will be different. So here this volt will be passed to V, small R1 will be passed to R1, and small R2 will be passed to R2. So this is my parameterized constructor. Once this has been done, so what I can evaluate? I can evaluate equivalent resistance. So equivalent resistance, and so the equivalent resistance for this particular circuit will be what? This will be R1 plus R2. Okay. Then what we can do is we can evaluate the equivalent resistance and the current. So the current, let us write I. Okay, the current will be basically, look here, the current is nothing but V by equivalent resistance. Okay, so it is written V divided by equivalent resistance, and this is the one. Sorry. Once the current is also evaluated, then what we can do is we can evaluate the voltage drop in R1 and voltage drop in R2. So double voltage drop in R1, and that will be equal to, that is what, if you look, it is I times R1. Okay, so it is I times R1. Similarly, you can also evaluate the evaluate the voltage drop across R2. So voltage drop across R2 will be I R2. That's it. Simple. So once this all has been done, what you can do, you can also create a display function, display, and here you can output all the things. So what is the source voltage? So that is nothing but V. Okay, then you can say what is R1. So R1, and it is nothing but R1. Then your R2, then once this is done, then we can give write the equivalent resistance. So R equivalent will be equal to R eq. Okay, so this is basically a function. If you look here, so this is the one, and then current, circuit current, we can say circuit current will be equal to it is I. Okay, then voltage drop across R1. So see out voltage across R1, and no, it is basically VR1. I can copy here, and then L, and in the similar grounds we can also write the voltage drop across R2. So voltage drop across R2 will be this one. That's it, done. So in the main, what is required? So let us create one. The name of this particular class is series circuit. So series circuit. So let's say circuit 1. Okay, and let us pass the data here itself. So let's say that the voltage is 5 volt, resistance 1 is 1 ohm, second resistance is, let's say, 2 ohm, and once this has been done, then circuit 1 dot display. That's it. So everything is over. So if you run it, it will say that the voltage source is okay. You can do what? You can also write volts and ohm and so on. So the equivalent resistance will be 2 plus 1, that is 3, and the current in the circuit is 5 by 3, and voltage across R1 will be this current into R1. So this is nothing but this one, and across R2 is 2 times this value. So this is the one. So in this way you can write your simple class for the series case. Similarly, you can also write the same thing for the parallel case as well. So what you can do is, let us copy this, because majority of the things are going to be the same. So if you copy this, and paste it here. Just change the name from series to parallel circuit. So this is not going to change at all. Now the constructor will also remain the same. Now comes the equivalent resistance. Now equivalent resistance will be what? If you look here, for this case it is 1 divided by 1 by R1 plus 1 by R2. So it is 1 divided by 1 by R1 plus 1 by R2, and then once equivalent this is clear, then you can do what? You can evaluate the current in different portions. So current in branch 1, current in branch 2. So let us say it is I1, and for first branch, and for second branch it is I2. Okay. So what is current in branch first branch? It is nothing but V by R1. So if you look here, it is V by R1. In the second, it is V by R2. So current in first branch will be V by R1. In the second branch, it is V by R2, and the total current will be the sum of these currents. That is I1 plus I2. Once this has been done, then what you can do is you can this evaluated, this is evaluated, this is evaluated. Oh, everything has been done now. So so this is not at all required. You just have to display. So now we have to focus on display. So this is the equivalent resistance is R equivalent. Okay, no problem. The circuit current I is this total I, or we can also do what? We can write for different resistances. So the current in branch 1 and likewise the current in branch 2. So this will be what? I1, I think, and this is I2. Let us check. So I1 is this, I2 is this, and then comes the total current, and that's it. That's it. So equivalent resistance in branch 1, branch 2, and then the current, and that's it. Now you have your answers, all the answers. So if you do this, so let us say circuit 2, and let's say it is 2 only. So 2. Okay, and if you run it now, so okay, you have to change this object also. So there is a problem. Okay, the name has to be same. The name of the constructor should match the name of the class. Remember this. This is a very fundamental thing. So now if you run this, then for the first one, this is the case. For the second one, this is the case. So the equivalent resistance will be 1 plus 1 by R1 plus 1 by R2, and 1 divided by 1 by R1 plus 1 by R2. So what is R1? It was 2. What is R2? So it is 2. So it is 1 by 2 plus 1 by 2 will get, so you should get what? You should get equivalent resistance as, why are you getting 2? Because if this is 2, so it is 1 by 2 plus 1 by 2, so that is 1 by R equivalent, and this is 1. So R equivalent should come out as 1, not as 4. So let us see what is the problem with the code. So R equivalent is 1 by R1 plus 1 by R2 and 1 divided by this value. So that is what it is printing. It should print like this. So what it is saying, the equivalent resistance is 4. Current across the first one is 5 by 2, second one is 5. Circuit current is this, voltage current R1 is 2 voltage. Why it is doing like this? Okay, you know why this is doing like this? Because this is series circuit. So we have to be cautious not only in creating the uh, class, because this has to the the what we call it, constructor has to be this of the same name as that of the class, and at the same time while creating an object you should be writing the same thing. Or what we can do also, see out, so that there is a proper distinction. So now if you run it, now this is correct, perfect. It was my mistake, because the object has to be of the same class. Okay, so the voltage is 5, R1, R2, okay, equivalent is this, and this will be 2.5, 2.5, and the circuit current will be equal to 5 amperes. So that's it. So in this way, friends, you can create the classes with inbuilt functions, specifically the constructors. So now you must be having a good understanding of how to write a class, how to write constructors, um, default as well as parameterized, and copy constructor we will see in the next lecture. So in this lecture, till this point only. Thank you very much for watching it.